Hi everyone, and welcome to the first of two videos going through some past exam questions on topics sort of to do with transition metals. Some of these questions involve redox titrations. They're just sort of a couple of odd questions that I wanted to make videos on, basically. So this first question is, it looks horrendous, right? There's just this wall of text, basically, that we've got to try and get through. So let's try and understand what's going on here. So you've got this dimethyl glyoxime, okay, that's used to whatever, okay, if you say so. Is used to analyse nickel 2 compounds. An excess of a solution is added to an acidic solution of a nickel 2 compound. Aqueous ammonia is added, which precipitates out a nickel 2 complex as a red solid. Okay, if you say so. What are we doing here? A sample of a hydrated nickel 2 salt is analysed using the procedure below. So this salt, whatever it is, 2.5 grams of it is dissolved in acid, and this DMGH is added to it, right, like it says here. So then we add aqueous ammonia, again, like I said, and it's going to precipitate out this complex. Here's the reaction. Right, so this salt, whatever it is, we add this DMGH to it, we add ammonia to it, and we end up with this precipitate. Okay, so it seems really complicated, but actually, it's fairly straightforward, right? You got a nickel salt, you add this thing, you add ammonia, you get this precipitate. Okay. This precipitate is filtered, washed it with water, dried and weighed, and the precipitate has a mass of 2.57. Assume that all the nickel ions have been converted into that. Okay, so it's going to, right, fine. And they've given us the molar mass, that's nice. A second 2.5 gram sample of the nickel salt is heated in a crucible to remove the water of crystallization. Okay, so we're going to have to do a water of crystallization calculation here somewhere. And we end up with this much of the anhydrous salt. Right. Here's the structure of this weird looking thing, which hopefully we're not actually going to need to know because they've given us the formula mass anyway, so at least we don't have to work that out. So that just seems like that's for information's sake. What they actually want us to do is to determine a possible formula of this hydrated nickel 2 salt that we started with, right? And this is a 7-mark question. Okay. So we're trying to get back to this hydrated nickel 2 salt is what we're trying to work out what it is. So we're going, right, what is this, basically, is the question that they're asking us. And that is where your nickel ions come from here. So we're trying to work our way back to this, essentially. So where are we going to start? Basically, all of this can be ignored until we find some numbers, right? Let's just do that, actually. Let's find some numbers. So all of this is waffle, right? There's 2.5 grams here. That's going to be relevant. I've got a value here. I've got a value here. Right, let's just find all the numbers because those are the bits that we're going to have to do something with, right? Okay, so let's start here. We know we've got the formula mass of this thing, this nickel DMG2, and we've got the mass of it, so we can work out the moles, can't we? Moles is always a good place to start if you're not sure what to do. So let's do 2.57 grams divided by 288.7, yeah? So let's do that. 2.57 divided by 288.7 is going to give us the moles. 8.9 times 10 to the minus 3. So let's write something down here. It's going to involve a lot of switching between bits of paper, unfortunately. So 2.57 grams divided by 288.7 grams per mole. When I'm doing these sorts of calculations, when I'm doing any calculation, I always write the units with the numbers so that I can see what I'm doing. If I do that, I'm going to end up with a number that's in moles, right? So I'm going to 8.9 times 10 to the minus 3, and that is the moles of, again, just for my own benefit, okay, what is this? That's this nickel DMG thing. Just so I know what I'm doing. Right. Okay, so now we can see where I'm going here. If I've worked out the number of moles of this thing, then it said assume that all of the nickel ions have been converted into that. So that's how many moles of this nickel salt there must have been in the first place, because it's a 1-to-1 ratio. So let's just write down what we're working out here. So it's a 1-to-1 ratio. So there's 8.9 times 10 to the minus 3 moles of the nickel salt that we're interested in. Okay. Right. Let's go back here. Right, we've used that number then, and we've used that number. So we now know this, and we know that there were 2.5 grams of this nickel salt to start with. So now if we know that mass and the moles, we can use that and we can work out what the molar mass is, can't we? That's perfect. That's exactly what we want. So now if I do 2.50 grams divided by this number of moles, that's going to give me the formula mass of this nickel salt that I don't know what it is. Yeah. And I want to use this full number on my calculator, don't I? So I'm just going to do 2.5 divided by that answer. And 280.8, let's call that. And that is the MR of, and it's the hydrated salt, isn't it? We're going to have to do this water of crystallization bit. Okay, right, so now we can kind of see where we're going then, right? We know that that's the hydrated nickel salt. Now we're going to have to do this water of crystallization business. So that's where we're going to use these numbers at the bottom, right? And this is where I think the value of finding the numbers is then going, right, I've used those numbers, I've used that number, now I've got these two, I've got to do something with this, right? So we've got 2.5 grams of the sample again, and it's easy to remove the water of crystallization. We've got 1.38 grams. So let's work out the mass of water that's been removed, yeah? So 2.5 minus 1.38 gives us 1.12 grams of water. Let's write this down. Let's kind of draw a line here. So we've done 2.50 minus 1.38 is 1.12 grams of water removed. Okay. So then let's work out how many moles of water that is. So we do 1.12 grams divided by, it's going to be 18, isn't it? Grams per mole for water. Divided by 18 is 0.062. Moles of H2O removed. And then we know that's the moles of water. We want the ratio of that to the hydrated salt, don't we? Because the hydrated salt is going to be something dot X H2O, isn't it? We're going to have this nickel, it's kind of awkward this, isn't it? We're going to have nickel and let's say some kind of Y as the negative ion that we don't know what it is, dot X H2O. And we want to know what's the ratio, we want to know what this is. So that's the ratio of this bit to that bit. Okay, so we want to know the ratio of the number of moles of this to the number of moles of that. So that's the number of moles of water, and the number of moles of this whole thing is this many moles, isn't it? Okay, that's the hydrated nickel salt. So we can just do the ratio between these two. Okay. So if we then do 0.062 moles of water divided by 8.9 times 10 to the minus 3 moles of the hydrated nickel salt. Hopefully this comes out as, oh, I need that number back, don't I? Let me save that number on my calculator. Right, let's go back to this value, 2.57 divided by 288.7 is that, and let's store that. Right, and then we want to do the number of moles of water divided by the number of moles of the hydrated salt, and we get 6.99, right? So that's 7, isn't it? So therefore, X equals 7. So we've got 7 waters of crystallization. So that's good. So now we just want to work out what this negative ion here is. Okay. So what we can do for that then is we know what the formula mass of the hydrated salt is, now that we know that there are 7 waters of crystallization, we can take that away from this, can't we? And that'll get us the anhydrous one. So 280.8 minus 7 times 18 for the 7 waters. So 280.8 minus 7 times 18 is 154.8 grams per mole. So that is the MR of the anhydrous salt. Oh, and then we're basically done, aren't we? Now we can just take away the mass of nickel, and that's going to give us the other bit. So 154.8 minus, what's nickel's atomic mass? Nickel is 58.7. So if we take that away, minus 58.7 is 96.1 grams per mole. So that is the MR of the negative ion. Okay. Right. Then where do we go from here? Does it give us any other kind of a clue as to what that might be? Right, this can be used to analyse nickel compounds. Acidic solution. Okay. This is a bit of a horrible question, really. It's kind of a bit of... Yeah, I'm just looking at the mark scheme in the background here and thinking, how are you supposed to work out from there what this negative ion is? And there's a bit of a clue, but it's a bit of a horrible question, really. The clue that is hidden in here is that this hydrated nickel salt is dissolved. No, that doesn't make sense either, because it would have been the salt before you added it to the acid. No, I think they're just expecting you to recognise this, which is pretty unlikely. That's pretty mean. 96.1. I can't believe they've not given you any other information here. That's weird. No, the mark scheme literally just jumps to, and this is the answer. That's harsh. But 96.1, that is a sulfate ion. We'll just add this up just so this is, sulfur is 32.1 plus 16 times 4, which is 96.1. But how you're expected to just work that out of nowhere is a bit mean. Yeah, there isn't any working out anywhere. It just says once you've got 96.1, you should just know what that is. I don't think you'd be expected to do that on the new specification. That's a bit... I think they'd have given you a clue somewhere else. They'd have given you some other bit of information that you could have used to work it out. If they'd said, it's got sulfur in it or something, and then you go, oh, okay, take that away. Oh, then, then you get a bit closer to the answer. So therefore, we can write... I mean, it's a bit of a horrible question. But with all this information, then we can work out that this is nickel... And it was a nickel 2 salt, so it's going to be nickel 2 plus, and the sulfate ion is 2 minus, so it's just nickel sulfate. And then we worked out it has 7 waters of crystallization, didn't we? So it's .7H2O. That's the actual formula. So I think that's reasonable, apart from this last one mark. How you're supposed to jump from there to there is pretty harsh. But the rest of this is just a moles calculation to work out the formula mass there. And then this is a water of crystallization calculation from year 12, really. So hopefully that's not too awful. It's just putting the whole thing together. But in terms of what I want you to take away from this, it's looking at this question, because these questions are presented awfully, right? That looks horrendous. But little tricks like, I would say, go and find all the numbers and tick them off when you've used them. It's one way that you can just sort of sort through the absolute massive information that you've been given. All right.